So I want to do another example with you. Even in the context of implicit differentiation, you can be asked for a second derivative. And so don't forget that this notation just means the second derivative. It's a little intimidating at first glance, but it doesn't need to be. And so let's just recall that. We'll start by saying recall y double prime is just the second derivative here, d squared y over dx squared. So how do you do this? Well, I want to walk you through it. So you begin by finding the first derivative. And so step one is going to be to find y prime. Okay? So I'm going to begin by taking derivatives of my original equation, and I'm going to get 4x cubed plus 4y cubed times dy dx equals 0. So far, so good. Now I'm going to solve for dy dx, and I'm going to get 4y cubed dy dx is negative 4x cubed. And so dy dx is going to be negative x cubed over y cubed. So that's great. I found dy dx. I want to find the second derivative now at this point. And so what do? Well, I realize that I'm going to rewrite dy dx and just write y prime. And I'm going to get negative x cubed over y cubed. To take the second derivative, in some sense, it's just the derivative of the derivative. So that's easy enough. I get on the left side y double prime equals. And then on the right side, I want to go ahead and take the derivative of this expression using implicit differentiation. So I'm going to have to do the quotient rule. So I'll take the derivative of the top, easy enough. That's just a minus 3x squared, done, times the bottom, y cubed. Subtract the top, which is going to make it positive, times the derivative of the bottom, which is going to be a 3y squared times y prime, all over the bottom squared, so y to the 6th. Now, we've done it, but I don't like it. I don't like having a y prime in my answer for y double prime. So I'm going to plug in the formula for y prime, and I'm going to write this as y double prime is negative 3x squared y cubed plus 3x cubed y squared times our formula for y prime was negative x cubed over y cubed all over y to the 6th. And so now I'm going to write this as y double prime equals, okay, here we go, negative 3x squared y cubed. Then what are we going to get here? We're going to get a minus 3x to the 6th all over y. There's this extra y downstairs. That's too bad. I don't like that, so I'm going to multiply top and bottom times a y. And so I'm going to get y double prime is negative 3x squared y to the 4th minus 3x to the 6th all over y to the 7th. And so now, at this point, you could stop if you wanted to, but you should factor the upstairs and just see what happens. It turns out something surprising and almost magical happens. So I'm going to pull out a negative 3x squared from the both terms, and so I'm left with a y to the 4th, oh look, plus an x to the 4th. Make sure you agree with that. Now I'm going to remind myself, that seems really familiar, like deja vu, and I scroll back up to the beginning of the problem and I say, oh my goodness, this whole curve is x to the 4th plus y to the 4th equals 16, and if you're talking about the derivative to the curve, the derivative of the curve, you have to be on the curve. So anything that we plug into our formula, any pair xy has to satisfy x to the 4th plus y to the 4th is 16, and the same goes for the second derivative. And so you know x to the 4th plus y to the 4th has to be 16, and so you end up with a minus 48x squared over y to the 7th. That's the formula that we want for y double prime, and really there's quite a difference between this formula and this formula. You need to catch that that is the same, and you can simplify. Well, that's implicit differentiation in a nutshell. I know it may seem a little overwhelming with all the x and the y's flying around. Practice makes perfect. Practice, 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 and we're going to do a lot of practice problems in class together as well. So plan on being ready to roll next time you come to class.